Nicole, can you hear me okay? I guess Nicole is busy in the background there. Bigger format. So, ladies and gentlemen, if you just joined us, we'll be starting shortly. There's a few more minutes. There's lots of people signing in. My nice calendar. I'll rehearse. Heinrich, while we were talking, was my audio okay, was it? No breaking up, I hope.
No, you're all good, Dave.
All good, right. And Nicole, I think you're streaming on YouTube already. Do you want to just stop it and restart it so you just catch the beginning rather than all this waiting around bit?
It probably will take a good few minutes for it to go and come back. It's
Okay.
very touch and go, so it's best to leave it as it is.
Okay. Right. Well, I'll start the recording of the Zoom version anyway, so that's nice and clean. But still admitting people, yeah, another 8 people have joined us. So 2 minutes past, so we'll start everything at about 5 past. Yeah. Gone over 70. That's good. So, ladies and gentlemen, about 2.5 minutes in. So we'll start about 1 or 2 minutes time at 5 past. Hopefully everybody will be in by then. Still going up.
And just a reminder to everybody to keep their audio muted.
And you know, Nicole, you can do that as one of the hosts as well, yeah?
I do. I've figured it out. Every week I'm learning something new on Zoom. It's brilliant.
It's going to be on logo in as well. 4 more in. Okay. Get a drink. Okay, gentlemen, we'll be starting in a few seconds. Yeah, about 80 there, so I think that's enough. If there's more people due in, those over 100 have booked. They can join us later on. Okay, you're all set, Nicole? Take that as a yes.
Yeah, ready to go.
Okay. There we go. Oh, you haven't set me as a host. Or am I a host? Or co-host? Nicole, do you want to set me up as a co-host, do you?
Sorry, I had my mute on. I was talking to myself. You're co-host now. It's all done.
Great. See if this works. There we go. Start it again. Well, good evening, ladies and gentlemen, and welcome to this New Year public lecture of Astronomy Ireland. We're delighted to have Dr. Henrik McMillan this evening to give a talk about the James Webb Space Telescope. But first, a little bit about our procedure this evening. I'm David Moore, the founder of the club, editor of our magazine, Astronomy On magazine, which I know many of you get, but if you don't get the magazine, you're not a member, you're very welcome this evening. And hopefully you might join by the end of the proceedings as well. Roughly what we do at these monthly talks, they are monthly, this isn't just a one-off lecture, is that we'll have a main speaker who will talk about an area of their expertise. It can be astronomy, it can be space. And that happens usually on the second Monday of the month, all year round. You'll see lots of details on our website, astronomy.ie, in the event section. But for tonight, we'll also tell you a little bit about what's been happening since our last lecture, which was our December lecture, also known as our Christmas lecture. And then we'll tell you, after Henrik has spoken, about what's coming up in the sky. A new naked eye comet is coming, and also some events, and our February lecture itself. So it's got sort of a past, present, and future plan for the evening. And if you have a few questions about the Society or astronomy in general, you can ask those at the end. If anyone's just joined us, please make sure your video and audio is turned off. It'll give our speaker the main emphasis this evening. And also, if you want to ask any questions, you can pop them into the chat box, or we will also invite you to ask them verbally, put your microphone on at the end, the Q&A session, and ask them direct that way as well, if you're not shy. So that's our plan for the evening. Let's get on with it. So the first thing to tell you is that you're all very welcome to all of our members and non-members in all 32 counties around the country. We're very much an all-island body. Most of our members do not live in County Dublin, which is great to see. We're a good national group. 2020 was our 30th anniversary year. And during that time, Astronomy Ireland became the world's most popular astronomy club, a fact that we're pretty sure we still are. So do join Astronomy Ireland, very much for beginners, people with no interest yet in astronomy, but want to take this up as a hobby. We don't need you to have a telescope, binoculars, or anything like that, or know any of the stars in the sky. In fact, we cover space and astronomy. So whatever your interest is, do join Astronomy Ireland. Our existing members, please tell all your friends to do so. We want to keep that title of being the world's most popular astronomy society in Ireland. We have a monthly magazine, which I showed you a moment ago, called Astronomy Ireland. You can get a single copy in the post for a few euros, or if you sign up for the whole year, it's about €1 a week. Who can't afford that even in today's world? And you're therefore supporting the society as well and our monthly magazine, which will tell you everything to see in the sky. I'll give you the brief highlights after our main speaker this evening. For our members only, we also have a weekly email that goes out with other events, a reminder of what to see in the sky, anything new that's happened. So make sure you sign up to get that as well. There are these monthly lectures that the Society does. Members can get into them for half price. So if you're interested in going to more than one of these talks a year, do sign up for that reason as well. There are also evening classes that we run, big discount for our members also on those. They're taking place February 1st. I'll tell you a bit more about that. Details are on the website if you have to rush off after our main speaker. They run twice a year, February and October. So hopefully people will sign up for those. Thousands have already done so. We also do watches with telescopes. The next one's on January 25th. There was a very good one in December as well. We had some clear skies for that, glad to say. We're always battling the Irish weather. But we do them for when very interesting things are happening all year round. We try to do one about every 2 months or so, half a dozen of those a year. There is one really big one, though, that you should all go to every year. That's our annual barbecue under the stars up in the Wicklow Mountains. It's called Starbecue, and it's Ireland's biggest star party by far every year. It's set for the 9th of September. So just think 9th of the 9th this year. Go to our website, you can already book tickets, even though we haven't confirmed the speakers. That's our major event of the year, though. We give talks in schools. We're always trying to inspire the future as well. And we have a huge media presence that you'll be supporting by joining the Society too. We've been on radio 2 or 3 times today, several times last week, and several times every week. We do hundreds of media interviews all year round. And we also have a big presence on social media. So when you go to astronomy.ie for free, you can follow us on Twitter, Facebook, Instagram, even a bit of TikTok going on there. Thanks to all of our volunteers who help us run that. That's a bit about what Astronomy Ireland does. Hopefully everyone has joined us by now and get on with the real news, which is our last lecture was our Christmas lecture. It was all about the Star of Bethlehem. If it was an astronomical object, what could it have been? Now, if you're at the lecture on the 12th of December, you'll know. If not, you can actually get these talks on DVD or online, going back if you go along to our website. And I'd recommend that to you. It's a fascinating story, looking back 2,000 years of astronomy to what was going on in the skies around the time that Jesus Christ was born. After that, we had the Geminid meteor shower, best of the year. It was a balmy minus 11 degrees Celsius. And we went on RTE Radio 1 and told everybody to get out and sit out in the lovely balmy temperatures like that for many hours that night and watch the free celestial fireworks display. I'm glad to say a lot of people did take our advice, me included. I saw some amazing fireballs and meteors from the Geminids last year, even though there was a bit of moonlight around. And there'll be a big report going into the next issue of the magazine, distilling all those sightings that people made. And then we moved into the new year, and we had a preview that we do every year with the journal.ie of what's coming up this year, the eclipse, the comet, the planets passing very close to each other, and indeed behind the moon. You can actually still see that on the journal.ie. Search for Astronomy On, you'll find it. It was released on the 1st of January. And we also did it on News Talk, talking verbally on nationwide radio about it. If you go to astronomy.ie/audio, you can listen to that after the talk or tomorrow and get ready for what's coming up during 2023. Some fascinating sights to see. I'm really going to enjoy telling you about the naked eye comet that's coming. I've already seen it myself, even though it's not nowhere near its best yet. Then on New Year's Day, to kick off the year, the planet Uranus went behind the moon. And for once it was clear. I managed to see it. Now you'll need a telescope to see Uranus going behind the moon. Other planets are going to do it this year. You won't need a telescope for. But a lot of other people saw Uranus going behind the moon, as we alerted them to in the magazine and the weekly members email as well. Hopefully you got to see that. January the 3rd, then Mars passed very close to the moon. And we had good media coverage of that. I got to see it. Didn't pass behind the moon, but very close. So another great start to the year. Been very busy with the media this year in particular. Then the news that's been happening today is, of course, any moment now they're hoping to launch Virgin Orbit satellite that will launch the first satellites technically launched from British soil ever, although they did launch some from Australia in the 1970s. So it's a big day for Virgin Orbit, which is part of the Virgin Galactic Group owned by Richard Branson I'll tell you a little bit about that at the end. And we sent out in our social media links to when to see it, when to watch it live on their YouTube channel. So check those out. You have to rush off. Check our social media, follow the links there, and you'll be able to watch it tonight after this talk. Nothing happens till after 10. You have plenty of time. Stay with us till the end. I'll tell you about that comet later on. I've already told you about the evening classes, and I'll tell you about our next talk, February 13th, day before Valentine's Day. You have to rush off. Just keep an eye on that date. So very active Astronomy Society, as you can see, lots coming up in the future. But as I said, every month we like to have an expert in their field talk about something of great interest to anybody with an interest in space. I mentioned earlier, anyone who's just joined us, if you have any questions, don't interrupt the talk. You can ask them at the end, and you can pop them into our chat box here on Zoom in the meantime, or we'll ask you to say them out verbally as well if you want to ask the speaker one-on-one. So let's get on with the business of the evening. As I said, we're delighted that Dr. Henrik McMillan, who's a James Webb Fellow at the University of Leicester, can join us this evening to talk about the James Webb Space Telescope, some of the results that are in his plans to use it for solar system studies in particular. There is Irish involvement, I'm glad to say, in the James Webb Telescope. We've had Dr. Patrick Kavanagh give at least 2 talks to the Society about the Webb Telescope, including the first results back in July. And at 10 billion euros, it's a telescope we're likely to come back and focus on a few times in the future. We already have a Webb Telescope page in our magazine every month, and there's always too much to go into it every month as well. So we're going to learn a lot from this telescope. So we're really keen to hear what Henrik has to say this evening. He's previously worked on the Cassini mission to Saturn. Those of you who've been with us for decades will remember we've had several talks about the extremely successful Cassini mission to the planet Saturn, now ended unfortunately. But we've now got the Webb Telescope, and we're absolutely delighted to ask Dr. Henrik McMillan to give our New Year public lecture for 2023 on his work with the James Webb Telescope. Over to you, Henrik.
Thank you very much for that introduction. It's a real pleasure to be here today. Let's see if I can share my screen first. Can you see that?
Yes, looks good.
Oh, excellent. Okay. Yeah, it's really great to be here this evening. And I want to talk about the James Webb Space Telescope, the most complex, the largest, and the most advanced telescope ever launched into space. I want to start off, though, by introducing myself a little bit. I was born in Sweden, and I grew up in a town called Örebro. And on the left there, you can see a movie of the Northern Lights captured very close to my hometown. Now, I'm ashamed to say that I've never seen the Northern Lights of the Earth, and we'll come back and talk about that a bit later. I became interested in astronomy by just taking a course at college. I was young. I didn't know what I wanted to do, what I was interested in. And a good friend of mine, actually my neighbor, decided to take this astronomy course. And I just, okay, I'll take it. It'd be fun to hang out. I thought I didn't know anything about astronomy, no expectations whatsoever. But I came to absolutely love it. And it's just so much out there, and so much of it is just truly fascinating. So I really fell in love with the subject. And so my dad turned 50 many, many years ago, and we went to London for a trip. And on the way out, I bought this astronomer magazine, Astronomy Now. I'm not sure if that's still around, but Astronomy Now had this education supplement in the middle. And I thought, oh, I could study in London, which seemed like an incredible adventure, and I could study astronomy at the same time. 2 birds with 1 stone. And so that's what I did. I went to UCL in London, and on the right here, you see the teaching observatory facilities that they have at UCL. Truly astonishing pieces of equipment. So that was really the biggest adventure of my life, moving to London and starting to study astronomy. So since then, I've been working studying the giant planets, Jupiter, Saturn, Uranus, and Neptune, using telescopes on the ground. On the bottom left, we have the Very Large Telescope out in Chile, which is a magnificent facility. I've also, as mentioned earlier, I worked on the Cassini mission to Saturn, studying the northern lights of this ringed planet. And recently, I've been working on data from the Juno mission, which went into orbit at Jupiter in 2016. And it's still going strong, so we're hoping it'll continue for a long time. So I'm going to start at the beginning. So why do we even want to put telescopes into space? Why is that a good place to put our observatories? Well, it's a picture of an observatory just outside Dublin. And actually, this is Dias. They have a research facility there called Dias, and they do some James Webb research as well. But the reason why observing, especially from Europe, is hard to do is that there's lots of clouds, especially this part of Europe. Weather is pretty inclement. You can get a few, I don't know, 30, well, maybe like 60 good nights a year, something like that. And also you observe through a lot of atmosphere, and this little movie of the moon shows you the turbulence of the atmosphere distorting the image we record through our telescopes. So one way to solve this problem is to move higher up in altitude, so basically move up a mountain. And here is Mauna Kea, one of the premier observing sites in the world. It's about 4,000 kilometers above sea level. And on the left there, you see the Keck 2 telescope, the largest optical telescope. It has a 10-meter mirror. So this is an excellent place to do observations. But you're still observing through a little bit of atmosphere, which introduces a little bit of distortion in your observations. So what's the next big thing? Well, I mean, since the 60s, we have some sort of space telescope present in space, but really the most famous space telescope there is, until JWST, of course, is the Hubble Space Telescope. And it was launched in April 1990, and here you see the launch taking off from Florida on a space shuttle into space. This was the promise of Hubble was to be an extraordinary facility, giving us completely new eyes on the universe, operating in the ultraviolet and the infrared. However, there was a bit of a shock when the first images were beamed back to the Earth. And actually, famously, the Hubble Space Telescope was out of focus. And so the images that the telescope returned were actually not that much better than we could do from the ground. And that's because the primary mirror, you can see actually on the right there, there's this New York Times front page news of the observatory is severely underperforming expectations. And it was a huge embarrassment to NASA at the time. You spend billions of dollars on this telescope, and ultimately it didn't quite work. And so, yeah, huge disappointment. So the reason the telescope was out of focus was that the primary mirror, the big mirror, was out of focus. So here's an old school picture of the primary mirror. So the one that was sent to space is on the left here. It was made by the Perker-Elmer Corporation, and it's off basically by the width of a human hair. And that's all it takes for throw the whole optics out of focus. Incidentally, there is a mirror that was made by Kodak, which is now in the Smithsonian in Washington, D.C., which was absolutely the perfect shape. So if they picked the other one instead of the Elmer Corporation one, they would have had a functioning telescope, and there'd been no embarrassment for NASA at the time. Luckily, the Hubble Space Telescope was designed to be serviced in orbit by the space shuttle. And in 1993, the first mission went up to service the space telescope, and it fixed the focus problems that it's had for the last 3 years between 1990 and 1993. And the images returned since then have been absolutely revolutionary, as promised by the whole project. So the telescope has been serviced 5 times, and the last service mission was in 2009. However, the space shuttle has gone out of service. The last space shuttle flight was in 2011. And so at this stage, the Hubble Space Telescope is showing signs of aging. It has gyroscopes that are sort of not working properly. It had some computer issues last year.
And so it's a telescope that's really showing its age at this point, but it's still working, and long may it live, because it's been truly transformational how we think about astronomy and how we think about the universe. So here's just a few of my favorite Hubble Space Telescope images. We have the Cone Nebula, the star-forming region, the Sombrero Galaxy with this dust ring on the dust lane on the outside, probably formed by collision with another galaxy. We have the Ant Nebula, which is this bipolar supernova. So there's a binary system. One of the stars goes supernova, the other star disrupts the whole explosion, and you get this hourglass sort of shape. Pretty stunning. And of course, Hubble has spent a lot of time looking at one of my favorite targets in the night sky, which is, of course, Jupiter. So even before the Hubble Space Telescope was launched, people were already thinking about what kind of facility are we going to need in the future? What are we going to need what shall we replace the Hubble Space Telescope with? Well, so people started talking about the next generation space telescope to have all kinds of designs. How do we best do it? There's a picture there on the right showing a telescope on the moon, which would have been cool, maybe not very practical. And so work started in the late 80s and really ramped up in the 90s. And so it's been a project that's been going for decades. It's taken a long time to get where we are today. However, if we look at the headlines published in the press before launched, it wasn't all rosy. Every single headline associated with the James Webb Space Telescope painted a picture of a project that was in dire straits. So in about 2011, there on the top right, you see a headline saying US lawmakers vote to kill Hubble's successor, and Congress, the American Congress, voted to cut the project altogether. A senator from it's called Barbara McCluskey, where the Space Telescope Science Institute is located, stepped in and saved the project. And in her honor, the actual archive for both Hubble and JWST data is called the McCluskey Archive. She saved it. She saved the whole project. There's been a number of launch delays. So every single year, it seems like the launch got pushed back further and further. There was an incident when they did the acoustic testing. So they stick the telescope in a big box and play lots of sounds, simulating basically the sound of the launch, the acoustic tremors that pass through the telescope as this launches out into space. And so they did this test, and at the bottom of the test chamber, they found like a handful of screws and washers, and people look at each other like, where are these coming from? So back to the drawing board, trying to design this so things don't fall off when you launch the telescope. So parallels have been drawn between the failures of the Hubble Space Telescope and the James Webb Space Telescope. But we got to launch day. This is 2021, Christmas Day, and we saw this. This is an Ariane 5 rocket in French Guiana. That's the European spaceport. So it's a European rocket carrying this international mission into space. And what we saw was an absolutely perfect launch. I mean, this is Christmas Day. I don't know about you, but Christmas Day, you're allowed to have a little drink about lunchtime, and that worked out really well because this was about 12:20, so just past midday, just to steady your nerves in case anything went off script, right? And so everything went perfectly. It was a beautiful launch. About half an hour later, we got to see the observatory detach from the launch vehicle. And here we see it moving out into outer space. And we're about to see the first out of about 340 individual deployments. So the telescope is folded up. I'll show that in the next slide. And there we see the solar panel fold out. So now the observatory has power, which is obviously critically important.
And so 340 individual things needed to happen for the telescope to fold out. If any one of those failed, the mission would have been severely compromised. But none of that happened. So here's the sequence in which it folds out. We have the solar panel, the communications antenna, and we have this massive sun shield that's about to fold out there. It takes a little while. This sun shield is a critical component of the observatory. It's 5 layers of aluminium coated Kapton, basically, your space blanket, that kind of thing. So you have 5 layers separated by some distance, not very much. This protects the telescope. This protects the mirror, I should say. It protects the mirror and the instruments from the hot rays of the sun. And so you can see that the layers just separating there. It protects from the hot sun. So at the bottom here, where the sun hits the spacecraft, it's about 50 degrees Celsius, so too hot to the touch. And on the shadow side is about minus 240 degrees Celsius. So this is a passive cooling system that keeps the mirror and the instruments extremely cold without any effort. It also, you remember Hubble's got this basically a tube sticking out of it, like a baffle, which protects the mirror from space grains and things like that, micrometeoroids. The James Webb Space Telescope doesn't have that. It doesn't have it because it makes the telescope a little bit cooler. And so it's just a way to keep the whole system as cool as possible. And why do we want a cool telescope? Well, the cooler the mirrors are, the cooler the instruments are, the less noise there is in the data. And the less noise we have in the data, the further we can see back in time, for example. The less noise we have in the data, we can actually resolve those first galaxies in the universe. So it's critically important that the telescope is kept cold. Now, the whole project is, of course, an international one. You build something for $10 billion. You want to make sure that everyone's involved and everyone financially chips in. So it's a partnership between NASA, the American Space Agency, ESA, European Space Agency, and CSA, the Canadian Space Agency. Those are the main partners. I work at the University of Leicester, and we've been involved for decades in this project because it took decades to build, obviously. And so here we have on the right, we have a picture of one of the 4 science instruments on the James Webb Space Telescope called MIRI. And Leicester built parts of that instrument. We got some data through yesterday of Uranus. And so this morning, everyone's running around like headless chicken, excited, to see this data, to see every bit of data we've got in from Uranus. It's absolutely, I can't show it to you, I'm afraid, but it's absolutely breathtaking. And it's fun to think that that data was taken with an instrument that was partially built right here in Leicester. So there's a real local connection with the images and spectra we take of the universe. A little bit more about MIRI, perhaps. So MIRI is one of the British instruments on the JWST, well, the only British instrument. It's led by Gillian Wright up at Blackford Hill in Edinburgh, where the Royal Observatory is. And additional partners are Rutherford Appleton Laboratory and, of course, the University of Leicester. MIRI observes Longwood, so between 5 and 25 microns. It's the only instrument on the observatory. They observe these really long wavelengths, and to do that, it needs to be a little bit special. It needs to be a little bit different compared to the other instruments, and that is they need to be even cooler. So we talked about the mirror and the instruments being about minus 240 degrees Celsius. That's 40 degrees above absolute zero. Extremely cold, right? I want MIRI to be much cooler than that. And that's because everything glows in the infrared. Everything has a heat signature at these wavelengths. And the cooler this instrument is, the more we're going to be able to see of the universe. And it uses this really clever thing called, oh, there's a sound on this. I'm going to mean to put the sound in it. I'll pause it. Don't know if you heard the sound, but it has this internal helium cryocooler, and it brings the instrument down to 6 degrees above absolute zero, which is very, very cold indeed. This is an internal helium, so it doesn't lose helium, so it doesn't run out of helium. So there's a closed system, very clever engineering to make this happen. But one consequence of having such a cold instrument is that you've got to be very clever about your engineering of anything inside the instrument. So here, this movie, if I can play a bit. This is the filter wheel. So you change between different filters to see different wavelengths and things like that. To turn the wheel, you have to turn on a motor. And every time you turn on a motor, you generate heat inside the instrument. And so you don't want to do that for very long because the instrument's going to heat up. So what you want to do is turn it on very, very quickly, and you let this mechanical arm put the filters in the exact right place you want it. So you see the arm at the top there. Another clever bit of engineering to make this observatory happen. So we talked about HST, Hubble Space Telescope, before as well. And an interesting comparison is, of course, the size of the mirrors. It governs how many photons you collect and send them to your instrument. So on the left, we have the mirror of the Hubble Space Telescope. It's a measly 2.4 meter mirror, which is, obviously large to send into space. But if you compare it to the mirror of the James Webb Space Telescope, it has a diameter of 6.5 meters, a whole different ball game. So it's made out of these 18 individual hexagonal elements, which are gold plated. I think I read somewhere there's enough gold in this mirror to produce basically 3 gold rings. So it's not very much gold, but gold is extremely reflective in these wavelengths compared to like silver or anything like that. Yeah, massive difference in size. The bigger the primary mirror, the more photons you're going to collect to your instruments. You can see those people down there for scale. So one other big difference between HST and JWST is that JWST is going to work a lot with spectroscopy. It's not just going to take images of the universe, it's going to divide the light up into its infrared colors. And the reason we do that is that it tells us much more about what the universe is made of. Each atom and molecule out there has its own signature when divided up into colors. So on the right, you can see different spectral signatures of carbon, nitrogen, oxygen, and iron. So say you're looking at a planet orbiting another star, maybe you detect nitrogen, signatures of nitrogen. Maybe you detect signatures of oxygen. That's just like the Earth's atmosphere. Maybe you detect signatures of water. And at that point, maybe you can begin to ask some very fundamental questions. Is there anywhere out there in the universe that's like the Earth that could harbor life? So about last summer, we received the first images from the observatory. And here's just one of them. Just wanted to show it. This is stunning. They call it the cosmic cliff. And you can see it's almost like standing on a cliff looking out into the infinite universe right there. And this is a star-forming region. So within this gas, stars are born, and then they burn brightly and die, causing supernovae. And you can see almost this cave-like structure inside this gas. As gas are lit, they actually push the gas away in sort of a bubble, creating this beautiful, beautiful structures. And there's so much detail in this. I think people are going to be busy. It's going to be PhDs just looking at this beautiful picture. So this is one of the first 4 pictures released. I'm going to show some other ones, I guess, shortly. The James Webb Space Telescope was designed around 4 different science goals. And I want to talk about them briefly because achieving these science goals has driven the engineering of the telescope. It's driven the design of the instruments and things like that. It is a general observatory. You can observe almost anything with it, but it's designed with these goals in mind. So the first goal is the end of the Dark Ages. So I always think about this. So the Big Bang went off. It was loud, it was bright, but as it expanded very rapidly, it cooled down. And at one point, there was no light in the universe. The first stars weren't born. There was no galaxies or anything like that. So it was completely dark. I like this analogy where you imagine you stand in a big stadium, at a rock concert or something. It's completely dark. There's no lights whatsoever. One person lights their lighter. I guess mobile phones these days, but let's take the lighter analogy. So one person lights one lighter, and there's one lighter lit in this whole stadium. That's the first star being born in the universe. Another person lights the lighter, another one, another one, another one. And soon the whole stadium is bathing in light from these lighters, these first stars being born. That's one of the targets of JWST. What do these first stars and galaxies look like? Something we've not been able to look before. So we're talking about a few 100 million years after the Big Bang, completely unexplored territory. And the observatory has already shown that it can do this. So here's an image released just before Christmas. So this is one of these, they call them deep fields, where you stare at a little patch of sky for a very long time, and you're trying to look at galaxies within it. And what you see, first of all, this is just littered with galaxies. And this is something you see in all the James Webb data. Wherever you look, you see a whole bunch of galaxies. And that's because the telescope is just so incredibly sensitive. You just can't help but seeing these galaxies. So there's two candidates. So we have a little box here called 1, which is this galaxy here, a little box on the right called 2. And these objects are some of the most distant galaxies we've ever seen. So a few 100 million years right after the Big Bang. So people are interested in their spectrum. What are these first, what's contained within these first galaxies? Obviously, they must be quite simple because it's mostly hydrogen. What kind of shape are there? What's the evolution of these galaxies moving forward? And that ties in to the next science goal of the mission. And that's the formation and evolution of galaxies. So here's in the background, I have this really famous Hubble observations taken by the Hubble Space Telescope in 2004. They're called the Hubble Ultra Deep Field. So here they stared at the same patch of sky for about 12 days. And 12 days is a long time to point a telescope at something. And so you can see all these marvelous set of galaxies popping out, some spiral galaxies, all kinds of galaxies. So it took Hubble 12 days to do this. Now, the next picture I'm going to show you, which is this one, took 12 hours. And that again tells you that the telescope is so incredibly sensitive. It can do things that took Hubble, weeks. It can do in half a day. Extraordinary. So this, I don't know if you saw this, but there was a press conference where this image was released by President Biden in America. It wasn't the best press conference, maybe, but it was nice to see the actual image. And this was actually the first science image released from the project. This other little galaxy, a little red dot, galaxy circled. At that time, that was the most distant galaxy ever seen, which has been superseded by the images I showed you a few slides ago. This record is going to get beaten and beaten and beaten again, because this is what the telescope was designed to do. This is cool. Okay, the third science goal is the formation and evolution of stars and planetary systems. So how are planetary systems born out of these disks forming around stars? So here's some beautiful images taken by the Very Large Telescope in Chile, showing these disks look almost a bit like galaxies, don't they? But these disks swirling up, within them, planets are formed. And so this has also been seen by the James Webb Space Telescope. And here's a really cool image. This is On the left, you have an image taken by JWST. Is somewhere in the Orion Nebula, so the background of molecular hydrogen, just gas, where stars are being born from. And we see one of these stars right in the middle. And this is, you can see the sort of protoplanetary disk, if you like, edge on. So the disk, we're seeing it on its side, which is why you see this dark band right across it. And this is on the right, you have an artist impression of what that actually looked like. And so understanding how planets form and how planets evolve, of course, has a role to play in how we see ourselves within the universe. The last, but certainly not least, science goal is planetary systems and the origins of life. So since the mid-90s, when the first planet around another star was discovered, we've discovered over 5,000 planets orbiting other stars. That's a huge number, and it's going to grow and grow and grow. And what we want to do is understand these different planetary systems. How do they evolve over time? What kind of planets are there out there? Is there anything that looks like the solar system? So far, it seems like the answer is no. But we're biased in detecting very heavy planets compared to light planets, terrestrial planets, for example. And so the James Webb Space Telescope has observed exoplanets already. And this is another outstanding press release. So we have, this uses a technique called coronography. And all you do, you put a little disk in the telescope above the bright star, because the star is generally like 10,000 or 100,000 times brighter than the planet. But just putting a little disk over the star, so the star is this star here, you basically remove all that light. And what you can see is this, a planet orbiting this star. And so this planet is about 6 to 8 times the mass of Jupiter, but is really, really young. It's only about 20 million years or so. And so we could think about this. Maybe what we're seeing here is maybe something like a young Jupiter in the early solar system. So by observing these planets, we can begin to understand how planets get to form to what we're seeing within the solar system today. Okay, so I want to talk now about what's really close to my heart, and that's what I want to use the James Webb Space Telescope for. So my bread and butter is observing the giant planets within our solar system. That's Jupiter, Saturn, Uranus, and Neptune. Probably doesn't need much of an introduction to this crowd here, but these are, of course, very large gaseous planets. Jupiter has this very famous Great Red Spot. It's the largest storm in the solar system. You can fit the entirety of the Earth inside that storm, which tells you how large these planets are. We have Saturn with its rings, and the very cold ice giants, Uranus and Neptune. And what I'm really interested in is actually the northern lights, the aurora of these planets. And here's a beautiful time lapse of the aurora, or northern lights of the Earth, taken from the International Space Station. So the space station is flying across the northern pole. You can see the lights right up in the atmosphere, the reds, the greens, the purples. So you can ask the question, what is producing the aurora? Well, it's actually charged particles impacting our atmosphere. Then you can ask, where do these charged particles come from? Well, one person that thought a lot about this was Christian Berglund, a Norwegian scientist, brilliant mind, apparently, brilliant and troubled mind, I should say. He wrote his first paper at 18. So who does that? I don't know. But he basically built a planetarella, which is a picture on the right there. He built Aurora in a box, and he postulated that the particles that produce the aurora, the charged particles, must come from the sun. So you need a magnetic field, and you need a source of charged particles. And he said it must be from the sun. And this is obviously well before the space age. The real first view we got of the space between the planets in the solar system was from Pioneer 5. It was a mission in 1960. It spent a few weeks in the sort of the place between the Earth and Venus. So it got to sample what interplanetary space actually looked like. And it was full of charged particles, just like Christian Berglund postulated. And these particles are thrown out by the sun all the time. So the sun, you don't think about the sun as a really active star in the sort of astronomical sense, but it throws out charged particles all the time. And all this stuff is wrapped up in a magnetic field as well, the magnetic field of the sun. So the picture we have today is that the sun throws out this material. It forms, in sort of a nautical analogy, the solar wind that moves out from the sun at terrific speeds, like, that's 300 kilometers a second or something like that, extremely fast. It reaches the Earth's magnetic field, and we're lucky to have a magnetic field because it protects us. It gives us this protective bubble from the solar wind. These charged particles generally can't get to us because we're protected by our own magnetic field. But some of these particles from the sun actually gets trapped by our magnetic field, and they stream down the magnetic field lines, they impact the poles, and we see Aurora as seen on the right there. So that's a basic principle of Aurora at the Earth. Now, what about Jupiter? Everyone's favorite planet. So Jupiter, of course, has a magnetic field, but Jupiter is everything on steroids, right? There's a magnetic field that is 20,000 times larger than that of the Earth. So it does form the same sort of cavity that we have at the Earth, but it's just absolutely massive. If you could see this bubble, we call it the magnetosphere, that Jupiter produces, it would be by far the largest thing in the night sky. So it's a shame we can't see it, but it's absolutely enormous. You can see this tail stretching off to the right there. It stretches all the way down to the orbit of Saturn. So this thing is absolutely huge. So we have all the ingredients, really. We have the solar wind, and we have a magnetic field. So what does the aurora of Jupiter look like? Well, the Hubble Space Telescope tells us. So here we have the northern lights of Jupiter. You can see there, so this is sort of a sped up time lapse, but it shows you, firstly, this thing is enormous because Jupiter is enormous. I put Earth over there to scale. And so it's just stunning, isn't it? I could look at this for days. So you see this main oval effectively, and you have all this emission sort of wandering about inside the middle. And so you can ask a similar sort of question here. Where do the charged particles come from at Jupiter? What produces the aurora at Jupiter? But actually, a clue is within this movie. And it's really tricky to spot, of course, but you see this little spot here? If you follow the magnetic field line from that little spot, you're going to hit a pretty magical space within our solar system. You're going to hit the volcanic moon Io. So on the left here, we have basically a thermal image taken by the Juno spacecraft of Io. And where it's bright, it shows you temperature, where it's hot. So bright equals hot, effectively. And so what we're seeing is a moon absolutely littered with volcanoes. And Io is the most volcanic place in the solar system. It's riddled with volcanoes. So on the right there, you have a movie taken by the New Horizons spacecraft as New Horizons flew out to Pluto. It flew by Jupiter and took this extraordinary movie. You can actually see a volcano throwing material out into the Jupiter system. So at Jupiter, actually, the solar wind isn't as important. It has its own source of charged particles right inside the system, and that is Io. So Jupiter's aurora is fueled by volcanoes. And that's just a mad statement, isn't it? Jupiter's aurora is fueled by volcano. I mean, I do this for a living, and it still baffles me that this is happening. You couldn't make this stuff up. It's amazing. And so that's the origin of the aurora of Jupiter. And so we want to study, for example, the northern lights using the James Webb Space Telescope. in July, we got our first images of Jupiter by the observatory, and they're absolutely stunning, aren't they? So this is obviously a false color image, but you can see the great red spot. You see clouds, these belts and zones of Jupiter. In red here, you can see the northern lights and the southern lights here at the bottom. Absolutely stunning clarity within these images. But we can actually do more. We can play around with the contrast of these images, and we see things we really haven't seen for a long time. So we play around with the contrast, and we can actually begin to see things that are not readily observable from the ground. We can see, most strikingly perhaps, we have the rings of Jupiter going around here, very faint, but extremely hard, if not impossible, to observe from the ground. We can also see maybe the Io footprint, the footprint I showed you in the James Webb, in the HST movies before. We can actually see this layer here. It's really difficult to see, but you can see there's a thin layer. That's the charged particle ionosphere, the charged particle component of the very, very top of the atmosphere, just popping out like that. You see these shepherd moons of the rings and other minor moons. Absolutely extraordinary detail. Another of my absolute favorite images by the telescope is this one. This is Neptune taken by JWST. And I talked earlier, like, you can't help but capturing galaxies wherever you point this telescope. And this is a great example of that. So we have Neptune right here. We have the moon Triton right here. In this entire field, you capture, I don't know, hundreds of galaxies, you know, for free of charge, effectively. So absolutely extraordinary. I mean, I'm sure someone's interested in all those galaxies. I'm interested here in Neptune. You zoom in a little bit. This is, you can see, oh, I love this image. You can see cloud features moving across the disk. You can see the rings of Neptune, shepherd moons of Neptune. And if you really squint your eyes, you can see this ring here. I don't know if you can see it. It's right there inside this bright ring here. This ring has not been seen since Voyager 2 flew by in 1989. That's how long ago since that ring was seen. And again, it tells you how sensitive the observatory is. And it tells you that we're going to learn a lot of new things that we've not even seen before by using data from this observatory. One more slide of the solar system. This, maybe you saw this, this is an image taken of Titan, you know, one of Saturn's most enigmatic moons. So we have really thick sort of nitrogen and methane atmosphere. And actually, we can even see, because different wavelengths can penetrate down to the surface, we can see the surface of the moon, and even one of the methane lakes contained on the moon, as well as cloud features. So absolutely mind-blowing. And I want to finish by just saying that this is just the beginning of the science phase of the mission. It's been about 6 months of science so far, and what we've seen has been truly revolutionary. We're hoping for 20 years of operation of this observatory, and imagine the things we're going to learn. Yeah, it's going to be amazing. And I want to say thank you so much. Thank you.
Thank you very much indeed, Henrik. I'll just take a quick look, see if anybody has any questions. While they're all typing their questions furiously into the chat box,
yeah,
or daring to speak out loud, you're definitely not going to show us those Uranus pictures from today by any chance, are you?
Ah, I wish I could. I wish I could. Oh, amazing.
How long before they're publicly released, do you think?
Well, actually, they're on the archive right now.
Oh. So
anyone can go and download them. So if you feel the problem is it's very complicated. It's very challenging data. So it's not images, it's spectroscopy. And so
it's spectroscopy, right? Yeah.
Yeah. And so, I think that makes me more excited than images, because it tells us more about the objects, the physical processes within them. but yeah, I think most of the solar system observations are publicly available, apart from this Neptune one. I mean, you can go and download the Jupiter data, for example, and play around with it. It's all publicly available.
Yeah, I think we've had some of it in the magazine already.
Oh, nice. Great.
All right, the questions are coming in. So do you want to look at the chat box, or will I call them out to you?
You can call them out if you want. Yeah. Well, I can do it. That's all right. So Greg asks, how vulnerable is JWST to micrometeoroids? Yeah, that's a great question. So early on in the mission, one of the mirrors was hit by a larger than expected micrometeoroid. We sort of project thought that this region of space was pretty well characterized, and maybe it is, that it's more of this, basically space sand flying around than we expected. So that's a worry for the project. So the limiting factors for lifetime is A, fuel, and B, the rate at which these things impact the observatory and damage it. So it is a risk, but it's being mitigated. So for example, for future observations, you're not allowed to observe, well, you're allowed to, but not really. You're not allowed to observe anything whilst pointing along the direction of travel of the telescope, which increases the momentum of these particles. So they are aware of it, and they're dealing with it in a sensible way to give us a telescope that lasts a very long time.
And then I see that, was it Clifford? Clifford Brown asks, how many science projects are using the Webb telescope?
That's a great question. I honestly don't know. So what I know is solar system, right? And we've observed basically every observable target we can. I mean, the major planets. So you can't observe anything inside Earth's orbit. You can't observe, obviously, you can't observe the sun. You can't observe Mercury, Venus, Earth, or the moon. But anything outside that we can observe. So observe Mars, Jupiter, Saturn, Uranus, Neptune. But there's lots of other little things as well you can observe that's not been observed yet. That's just within the solar system. Now, the universe is a big place. I think at this rate, I think we're looking at maybe, I'm guessing, about 200 different science projects every year of operation. And these are selected by a group of peers, and it's done very fairly, I think. And anyone can apply for time at this telescope. You can be from anywhere in the world doing any kind of science. You're welcome to apply.
And then I see Mick Dunn has asked, can you remind us of the name of the Aurora scientist? And I'll just add, before you tell them, I think it's Berglund, but we have run trips to Norway for the Northern Lights. You must come on one with us at some stage.
Oh, I'd love to. Love to, yeah.
In one of the museums, his actual equipment is on display, so we've touched it, shall we say.
Oh, wow. That's amazing. Yeah.
Want to give Mick the name again? I've forgotten his first name.
It's on the screen there. Christian Berglund.
Ah, yes. Yeah. That was a quick question. There you go, Mick. So you'll have to come on our next Aurora trip. Northern Lights, the solar maximum, I think, is due 2025, and the Aurora, for some reason, seemed to peak 2 years after that. So in a few years, we'll be reorganizing those Aurora trips. Next year, though, it's the April 2024 eclipse trip to Mexico. So watch out for that coming up in the future. Oh, wow. So let's see what other questions we have. Nigel asks, will the telescope need servicing, and how often does that need to ideally happen?
Yeah, that's a good question. The answer is it'll never happen. It's not designed to be serviced like the Hubble Space Telescope. And the difference is the Hubble Space Telescope orbits the Earth, which is pretty straightforward place to do servicing. James Webb Space Telescope lives at a point called Lagrange Point 2. Lagrange Point 2 sits anti-sunward of the Earth at a distance about 4 times the distance between the Earth and the Moon. So it's a very remote place. It's basically deep space. And we put it there because it's very cold. You can protect yourself from the sun, glares of the Earth, glares from the moon. So it's not designed to be serviced, and it's designed with this in mind as well. You know, there's all kinds of contingencies if things break. For example, every mirror can be individually focused. So say one of the mirrors did become damaged by micrometeorites, you can simply defocus that out of the field of view, and it's not going to be part of the image. You're obviously going to lose some sensitivity and things like that. The only thing, and this is a fun fact I learned pre-launch, fuel is of course a limiting factor. It has fuel for about 20 years, and that's in the high, much, well, the launch was so perfect, they didn't need to use a lot of the fuel to do course correction after launch. So there's more fuel than they expected, which is 20 years worth. Now, if it runs out, that's obviously, you know, you can't do course corrections when you're running out, when you run out of fuel, but there is an exposed fuel cap. But the spacecraft to refuel the observatory hasn't been designed, it doesn't exist, but just in case, they put in an exposed fuel cap in case someone wants to do it.
Probably a project for Elon Musk later on. Once trips to it, yeah. There's a question about extraterrestrial life.
Yes. It's a great question. So what we can do with JWST is to characterize the atmospheres of planets around other stars. I don't know if you, I've not really thought about this, but it's really interesting questions. I mean, could you, for example, if you observe, you know, greenhouse gases, for example, if you have an atmosphere that's a bit like ours, where greenhouse gases increase over time or something, could that be a signature of life? Yeah, it's an interesting question. I think there's not going to be a direct detection of extraterrestrial life per se, but we can say that this planet has the conditions for life as we know it. I mean, life could be something else somewhere else, right? But that's the whole point. We're going to characterize the whole range of planets out there in the solar system and to identify, are there ones that could perhaps harbor life like ours?
And next question I can see is there a picture online of Mars from JWST?
Yes, I think there is. I can't access my screen right now, but it must be on NASA's page somewhere, or ESA. ESA has a good archive as well.
Yeah,
it is out there. Yes.
I thought I'd seen one. It's obviously been at opposition in December, so it was ideally placed. But there've been so many pictures come back, I can't actually remember what it looks like. I'm sure we had it in the magazine as well.
Yeah.
Next question says, how is a moving, it's from Greg Robbins, how is a moving telescope kept pointed at a point in space for long enough to capture enough light to see these oldest galaxies?
Yeah, that's a good question. It's the old Newton's second law, I think. If you don't apply any force to something, it'll stay pointed where it was. But the telescope also has some help. It has these gyroscopes with which you can turn, incredibly sensitive. You can turn the telescope within, milliarc seconds and things like that. So it's extremely good at pointing the telescope in deep space. It's extremely clever. So it hasn't been an issue so far.
Mr. Keane asks, what new things would you like future telescopes to do?
That's a great question. I'm really excited about, you probably heard about the next generation of 30-meter telescopes. So there's one being built in Chile, or maybe it's two in Chile. They're thinking of building one in Hawaii. Now this is a ground-based telescope, but what's good about having telescopes on the ground is that you can change instruments, you can upgrade instruments, you can actually change things as time moves on and technology sort of improves. And you can do adaptive optics where you basically remove, through very clever optics, the atmosphere above you. So I think that's it's going to be a really fun place to watch in the coming decade.
Yeah, definitely. The 39-meter telescope, one of the chief engineers, now retired, was Irish. He gave
Oh, wow.
an excellent talk a few years before COVID. It's probably
Oh,
still on
okay.
our website if you go there and have a look. If not, email us, we'll find it for you.
Oh, great.
And I could just, main thing I remember from his talk was they showed a picture from the Hubble Space Telescope and a picture simulated as to what the 39 meter should show. And it made the Hubble Space Telescope look like a pair of cheap binoculars. So I think it's coming online 2025 or so, isn't it? First engineering images. It's not that far away.
It's not. No. It's being built as we speak. So
Yeah.
Amazing. Yeah.
Now, I remember in the magazine, we had the picture of when they cut the top off the mountain to
Yes.
sight the telescope. Okay,
Yeah.
next question then. Will the telescope be retrieved after its lifetime, or will it join the list of existing debris?
It will not be retrieved, I believe. It's just going to float around in deep space. It's quite sad to think about. Having just begun, it's that sad to think about its demise. But
yeah, let's give it a chance first. That said, existing debris, I think it's 3,000 times further away than Hubble is. So Hubble's close to the Earth, where there's all this space debris. A million miles from the Earth, space debris is not really that much of a problem yet.
It's not. Yeah, exactly. Yet, maybe in the future.
And then Mick Dunn asks, has JWST looked at the Oort cloud?
I don't know. I don't know the answer to that. I don't remember seeing anything about it.
I'm going to sneak in a question here, because this comet that we're going to talk about in a moment that could reach naked eye visibility.
Okay.
With Hubble, and I think with Webb, there is the director of the institute has his own sort of private time on the telescope for pet projects. And it seems to me that photographing the first bright comet to come around will be a great PR stunt. Do you know if anybody's planned that, being a solar system Webb user?
I've not heard anything, but I agree with you. It should be talked about. Absolutely.
Well, you probably have the mobile number of the director.
Yeah.
You wouldn't give him a call after the talk, please, and tell him Astronomer wants to put it on the front cover of the magazine.
Yeah, I'll give you credit though, of course.
And then we have from Sandra McCowan, would the meteor showers from passing comets affect Webb telescope?
Potentially, yes. They've obviously calculated the probability of anything substantial impacting on the telescope and decided that the risk was small enough so we can actually launch it. So yeah, anything flying in space is a risk. It's an extremely brittle observatory. It's extremely brittle. The sun shield is basically fabric. The mirrors are quite flimsy. Everything's quite brittle. So doesn't take very much to cause significant damage to the telescope. But all of this has been thought about, and risks have been weighed, I think. So yes, hoping it's not a problem.
We're coming up on an hour or so. So if you look in the chat box, you'll see that Tony Whelan has posted a link to the latest Webb images, so you can all have a look at that.
Excellent.
If they be searching for it later on. But we might leave the last question to our managing editor of our magazine, Leanne Fernandez, who's asked, he's not sure if you heard about this, but there was a new nebula discovered near the Andromeda Galaxy. Do you think Webb will investigate it soon? And another unrelated question, what are you hoping from the Aurora data you receive from the different planets? Which was exactly my question, but Leanne beat me to it.
Great. The first question, I've not heard about this nebula, but I'm sure people are on it. So actually, the deadline to propose new observations is coming up the end of this month. So if you want to, you can have a go at proposing. And I'm sure people are looking at it. It's not something I'm directly aware of. As for your second question, so I'm interested in how these planets interact with their surrounding space environments. And I'm interested in how the aurora actually changes the physical properties of the atmosphere. So imagine you're throwing lots of charged particles at the atmosphere. When you're doing that, you're actually changing the atmosphere and you're heating it up. And that's what I'm interested in. So how does the aurora change the properties of the atmosphere that would it changes it, and what would it otherwise be? So as part of what I'm trying to find out, there's an overarching thing that I'm trying to solve. We call it the energy crisis. It's not the energy crisis of today, where energy is really expensive, but it's the fact that the upper atmospheres of these planets are hundreds and hundreds of degrees hotter than we expect them to be. So that's the energy crisis. Where is this energy coming from? And one good candidate for that is the aurora. We have sunlight, of course, but these planets are really far away from the sun. So how does the aurora change the physical properties of these planets?
And I think that's a great point to leave the questions. So we're going to thank Heinrich for an excellent New Year public lecture and wish him all the best in his research and use of the telescope. Don't forget to ask the director for that comet picture for us, please.
Yeah.
In Ireland, we say it's not what you know, it's who you know.
That's right. Yeah.
It
Well,
probably
thank
will.
you very much for having me. I really
Our
do
pleasure.
appreciate it. It's been fun.
Well, I'm going to tell people a bit about that comet and the big event we have to watch it on January 25th. Heinrich, if you have to rush off and start analyzing your web data,
Yeah.
please do so. And thank you very much indeed. A very happy New Year to you.
Same to you. Thank you. Bye.
Okay, just to close briefly, quick note on what to see in the sky. Most of it's in your magazine. If you don't get the magazine, go to astronomy.ie and sign up today. The planets on view, Saturn is bowing out, very low now in the southwest, but Jupiter and Mars are blazing away. Venus is beginning to come into the evening sky, and by the next lecture in February, it will actually be visible. I've seen it in binoculars already in the strong twilight. So we're going to have 3 bright planets between now and the next meeting. Now, the comet is coming, but first, just briefly tell you about everything else. The International Space Station is starting to fly over evening skies from the 19th of January, so that's the end of next week. So there'll be details on our social media about that. We'll post daily predictions, not only of when to see it from Ireland, but when it's going to pass in front of the moon or the planets, or if there's a space chase, if they're sending new craft up or coming back. So watch out for all that on our social media. There are plenty of apps, but we think our Facebook, Twitter is the best way of keeping an eye on it. Of course, we'll also tell you, linking to our speaker this evening, whenever there's an aurora predicted for Ireland. We've had a few sightings last year. Not very good ones, a bit low down. They weren't directly over Ireland, but at least it was seen from Ireland. We carried those pictures in the magazine to prove it. What else happening in the sky? Well, next Wednesday, the 18th, we like getting up at dawn. The brightest star in Scorpius, Antares, will be quite close to the moon, about 2 moon widths away from it. There's a diagram for that in your magazine. Then on the Sunday week, Saturn is going to be very close to Venus in the sky. That's why I was getting ready to spot exactly where on my horizon it's coming up. So there's a diagram for that in the magazine, lots of notes about how to observe it. That's very close. That's within a moon width of Saturn that Venus gets. Now, Venus is about 100 times brighter than Saturn. You'll definitely see Venus with the naked eye. I don't know if you'll see Saturn, but you will in your binoculars. If you've got a telescope, great. You'll be able to see the disks of both planets. And the following night, Monday the 23rd, the moon joins them. They're still pretty close, about 1 degree apart. So about twice as far apart as they were the night before. Venus is moving very quick across the sky. But the moon joins in. That should be an incredible sight in your binoculars. A nice diagram for that in the magazine as well. One of the highlights of the month. It'll happen a bit low down in the southwest, so get ready well before then. And then the Wednesday after that, Jupiter's quite close to the moon. Not spectacularly close, but it's always a nice sight when you have the brightest star-like object in the sky, the dark night sky that is, when Venus is gone, next to the moon. So watch out for that. There's a diagram for that in the magazine as well. And then the moon starts to become a little bit less bright. And on Monday the 30th, second last day of the month, the Pleiades star cluster will be within the same binocular field of view as the moon itself. And again, we have a nice diagram for that. So they're the highlights to see with naked eye and a pair of binoculars. You can get a good pair of binoculars these days for less than 20 quid. You should certainly invest in those. Now, the very last day of this month, Mars passes quite spectacularly close to the moon, about 1 moon diameter away. That's even better than it was last week when on the 3rd when we were promoting it in the media. So we're definitely going to promote that one. It's a Tuesday morning. So they'll be close on the Monday night, but they get very closest that following morning. So a fantastic sight, Monday, Tuesday, January 30th, 31st. Now the comet. Okay, well, we had some notes about the comet in the magazine. And we're just saying it's bright and it's coming along. Comets are a bit tricky. Sometimes they let us down really badly by factors of 100, but sometimes they're equally more spectacular than we expect. I remember when lockdowns were beginning, we had 3 comets that we predicted were going to reach naked eye visibility. And the first one didn't. And the second one didn't. And when the third one came, I think everyone expected it wasn't going to. And in fact, it turned out to be the exception and was as bright as the brightest stars in the sky in July 2020. So we're hoping that this comet called ZTF, it's named that, it's an acronym for a telescope that surveys the sky, Zwicky Transient Facility, I think, ZTF. It's already got a lovely tail on it. Photographs coming in from experts around the world long before it's been closest to the sun. It's close to the sun on January the 12th. So it's not fully heated by the sun yet. Their pictures are amazing. It's visible in the morning sky from Ireland. I've seen it myself a couple of times in a telescope. But once it passes the sun, it gets its major heating on January the 12th. And it's usually after that comets flourish. And it's going to come closer to the Earth after it goes past the sun, as if to say, here, I've brightened up. Now I'm going to present myself to the Earth to watch me. And the other great thing about this is it comes closest to Earth on February the 1st, but it's going to be in the northern sky, perfectly placed for viewing from Ireland. In fact, it'll pass between the Plough and the North Star. Now, we'll have a map showing that in the next issue of the magazine, which will be out in the second half of January. It's been printed on Monday week, I think. So watch out for that. If you don't get the magazine, get it now. We'll keep you posted on the weekly members only email, and you'll have that diagram in the magazine. Don't miss this one. If you didn't see the naked eye comet in July 2020, shame on you. Don't let it happen twice in the same decade. So that's a little bit of a plug for Comet ZTF. Obviously, future issues of the magazine will be plastered with photographs of that particular comet. So astronomy.ie is where you get the magazine from. One last news note to tell you about, of course, tonight is the launch of Virgin Orbit's first British satellite, launched from British soil. It takes off from Cornwall from one of 7 new spaceports that the UK is building around the island. And it'll fly out over the Atlantic Ocean, and it's actually launched from Irish territorial waters. This is an Irish story, even though it's a British satellite. And they've actually asked craft in the area just off the southwest coast of Kerry and West Cork not to be in that area, just in case anything goes wrong. It's extremely unlikely anything would go wrong, but you have to err on the side of caution with these things. And anyone on the south coast might just see when they light up the rocket motors. I believe that it's been tricky to get the exact time. I believe that they're going to take off from Cornwall at about 10:15. It takes them about an hour to get south of Ireland, get ready, and then release the rocket. It'll be dark by then, of course, but the rocket will light up, and people on the south coast of Ireland might see it 1/4 to midnight. We're expecting. There's always a chance. In fact, while we've been at this lecture, there's a chance they've announced they're going to scrub because of weather. Certainly bad weather over Ireland, but there doesn't seem to be bad weather over the takeoff site. How that affects Virgin Orbit, I don't really know, because it's their first launch from that particular spaceport. So watch the news. If you go to our social media, you see we put up a link to the YouTube channel for Virgin Orbit, where you can watch the thing live from 9:15. They'll tell us the very latest story straight from the horse's mouth, as it was. A bit of excitement for the rest of the evening for you there. And if you don't have that link, I'd say if you search Virgin Orbit on YouTube, the link should come up. Now, the big watch we have this year to show you the comet is on January the 25th. Now, we'd organized this long before the comet came to prominence. It was our annual watch for people who've got telescopes at Christmas, don't know how to use them. It's a workshop. They can come along, bring their telescopes. We'll help them use and even assemble them sometimes. And as well as that, we were going to show people Jupiter near the moon that night. And it's exactly 1 week to the hour, to the minute before our evening classes begin. So it was also a promotion for those. So now it's going to be a telescope workshop, Christmas telescope workshop, a Jupiter near the moon, watch both of them in our giant telescopes, a comet watch as well, and a promotion for the evening classes. So wherever you are, January 25th, 7 p.m., it better be outside Astronomy Ireland's headquarters. Let's hope for clear skies. We'll be doing the workshop regardless of the weather anyway, if you've got a Christmas telescope. So bring your binoculars as well. We'll show you how to find the comet. Hopefully by then, January 25th, it should just have reached naked eye visibility. We're not sure how bright it will be. It could be faintly visible to naked eye, but who knows with comets? It might fizzle out. It might suddenly brighten up, break apart, and it would increase its brightness by a factor of 100. So we'll just have to wait and see. But if you want to watch it with us, January 25th is the date to remember. And remember, if you're interested in those evening classes, they're enrolling now. Lots of people have already enrolled. Thousands of people have taken the classes. They're being given by YouTuber John Campbell, who's got 50,000 followers, I think, on his astronomy site on YouTube. He's a member of the club as well. And he's just started doing our classes last year. They went down extremely well, so we can't recommend those to you more highly than that. Our next lecture to close is on the second Monday of February, the 13th. It's at 7 o'clock again, online here. This time, though, it's called Last Horizons, the Edge of the Solar System. So a bit in keeping with the theme this evening. And it's Dr. Steph Merritt, who's a research fellow at Queen's University in Belfast. So if you like solar system studies, that's a talk you can sign up for online now. Go to astronomy.ie. So just to close, don't forget to follow us on Facebook, Twitter, Instagram, for all those ISS times, Aurora alerts, other things like that. Do order the magazine or sign up for membership. If you're already a member, please get loads of people to join Astronomy Ireland. It's an incredible year ahead, as you'll see from that review we did with the journal.ie and News Talk already this year. So I don't think I've left anything out. I don't want to keep you too long. If any of our volunteers are still online and want to shout out anything that I've missed, please do. Other than that, we'll thank you all for attending our New Year lecture. Wish you all a happy New Year. And we'll see you on January 25th if you're in the Leinster area, and February 13th here online.
Oh, he's gone. Hello?
That sounds like Anne.
It is, yeah. I was just wondering, when is the next watch on? Did you mention that earlier?
January 25th.
25th, great. See you there.
It's the Comet Watch, Christmas Telescope Workshop, Mars, Jupiter and the Moon Watch, and the evening class promotion. 4 in 1.
Great. Thanks a million.
And it's on the website. Go along to astronomy.ie. If you forget, you'll see it there.
Thanks, David. That's great. See you then.
Definitely.
Bye.
Bye-bye.
Thanks a million, folks. Cheers.
Right.
I don't see any other queries in the chat box, so unless anyone else got any comments or questions, we'll call it a night and we'll see you all again soon.
I think you've covered it all, Dave.
Yeah, plenty happening this month.
Yes,
Incredible
absolutely.
start to the year.
Absolutely. Good night, everyone.